All right, we're going to get to prototyping out a part. I went out and shot some footage on site at a friend's house where the truck is located, and I'll go ahead and play that. Okay, here's the next project we're going to work on. This is going to be a nice little restoration of this Dodge here, and they want to get rid of the dually in the back. They want disc brakes. So over here we've got the rear end that's going in. This is a drum brake rear end. So what we have to do is convert this right here. So what we have to do is we have to kind of reverse engineer this bracket and then make the offset change for the depth of the rotor. So what you'll see here is I've got set up on the Bridgeport with the new DRO. Got this guy bolted down, and kind of what I did was use a parallel as an edge, and I've got the edge of that guy right on the parallel, both of these guys. So basically, to find the centers of these holes, all I have to do is sweep this, set this at 0, the center of that at 0, and then come in here, and I'll probably just use a drill bit that fits really close, plunge, and that'll give me a nice offset in the Y-axis. And then I can also go from side to side, see if there's an offset from 0, you know, basically just locate these two holes off of the center of that one. So that's what we're going to do. So yeah, it's pretty darn good for as rough as that is. It's you know, it's within a thou or two. And the first part we make is just going to be a prototype part. Make sure everything fits before we cut everything out of steel. So what we do now is fire up our new DRO, set X and Y to 0, and then make the moves and find out where these guys are. Okay, here you can see the assembly that I kind of just threw together. The caliper bracket is not correct, it's just a representation. But there's the axle tube, and the red thing is the bracket that we have to make to adapt the axle tube to the caliper bracket. So we'll open that one part, and this is the thing that we have to cut. This will be a prototype. We're going to cut this out of aluminum, and what's critical is this face to this face. So this is the face that bolts to the axle flange, and then this is the face that bolts to the caliper bracket. So as long as those distances are represented by the prototype, thickness of the material really doesn't matter at this point. When we cut it out of steel, the final part, that will matter. But for this prototype, we need the holes, and we need those spacings and kind of the outline of the part. So that's what we got to do. Okay, I found this chunk right here. I think it'll work. You know, it's 2.5 inches thick, but it'll work. So I got one line on here, and what we'll do is cut that off, and then come over a 7.5 plus, square that up. Okay, for everybody that's never seen high-speed sawing on a bandsaw, this is set at 3,000 RPM, and like I said, this piece is 2.5 inches thick. So I'm going to show you how fast this actually works. Little wax on the blade, keep the chips out. Okay, that was a solid, well, you know, put it in perspective. That was a solid 3.5, 3 3/4 inch cut. What'd it take? Minute and a half? All right, we got the part imported into Mastercam, and this is kind of what we're going to do. Just start off by contouring around the outside and removing all this excess material, and then we can do some profiling of all these surfaces and get rid of all the rest of this stuff. So yeah, just want to make a big trough around the outside of this guy and clear it out. So let's see, down here I generated the code, and it's not too big, but yeah, we're going to use a 3/4 inch 3 flute end mill, and we're going to spin it at 4500 and move it along at maybe, I don't know, 35, 45, 50 inches a minute, something like that. We'll decide on the machine based on how well it's cutting. Of course, I'm using coolant. And yeah, I've sent this out to the machine, so let's get cutting. There we go, we got the program loaded up in the machine, caliper bracket, and I have set the X and Y 0 point about right here, and touched the tool off. That here came off and went down, I think 20 thou, just so I'd clean up all the surfaces. I have 2.15 to my jaw, and I'm cutting 2 inches and 50 thou down, and that'll be 10 thou past where my finished surface is. So this should function. So let's close the doors and give it a see. Windows are a little dirty. Just moving slowly at first. Oh yeah, big lead in. I believe this will work just fine. And I'm doing 2 passes around this thing with a 1/2 inch separating the 2 passes. So this one will be pretty close to the finished shape. I'm leaving 50 thou on the sides for cleanup later. Just caught it there. And now we're just roughing out the hole on the inside. Still just getting rid of material. This is a dynamic OptiRough. Alright, the hole is cut, roughed in at least, and now what we're doing is more OptiRough. Real shallow step downs, like 80 thou, something like that. And what we're going to do is just kind of use this square end mill to rough in the shape. And that may be how we leave this prototype part, instead of going in with a ball and finishing all the radiuses. But we'll see what it looks like. This is cutting a lot of air, kind of a waste of time, but I'm just going to run this while I'm at lunch. So no big deal. So there's where we're at after the roughing. This surface is down to 0. I still have to flatten this off to 0. What we're going to do now is, since I left 50 thou in here, you can see where the shank of the tool rubbed here. What we're going to do now is we're going to do a 3D contour around the outside of this guy, and then bring this hole to size, and we'll go from there. Okay, there we go. One side done. All the holes, all the profiling. Now I just got to bring the faces down to depth on the other side. I don't know how I'm going to hold this. That's the next thing we got to work out. Alright, so there it is flipped over. Now you can see why I bored this hole all the way through from the other side, so I could locate the part based off of that hole. As you can see, I don't know, over here, there was a hole in my stock, and right there. Right in there. There's a hole in the stock that shouldn't have been there, but you know, this is just a prototype piece, just so we can make sure it fits before we cut out of steel. I'm going to leave these steps in there, just not necessary to fine tune that with a ball. You can see I used positioning jacks to keep this from vibrating. It worked just fine. And so now I think what we're going to try and do, maybe, if it will work, I don't know, we'll see, mount this in the lathe and just spin this surface off. It might be the quickest, easiest thing. We'll see what I come up with. Okay, so to take that last little bit, I got to take that chunk off right there, bring this to size. I think this is 3/4, 7.750. To do that, I pulled 3 jaws out and was able to position these legs where they're not contacting anything, and grab the bore, and I'll just spin that guy down. Alright, we finished this part all up. It's like I said, this is just a prototype part. The real ones are going to be made out of steel. This is just to make sure we're clearing everything we need to clear, and the holes line up, and the caliper offset is proper for the rotor. So yeah, we'll have a look at it. So there it is. I mean, you know, is what it is. Like I said, there's a little hole drilled right there that we didn't need, but yeah, that was just in the stock. This is good enough for what we need. So the final one we'll do with a ball and fix all this up really nice, and it'll look great and function just fine. So the next thing that we're going to work on, I think the next thing should be the rear axle to my car. So the 1932 Ford Roadster, this is the fabricated 9-inch Ford. It's got a little bit of Hawaii rust on it, so we're going to clean it up. And one of the problems that I had was I did not have enough clearance for the side bearing retainer clips in this area right here. So probably going to stick this in the CNC and just open this up so we have plenty of clearance all the way around. That might be the next thing that we work on. So we'll get this part to its owner, and we'll see if it fits, and then source some material and cut some out of steel. Hope that was entertaining. Stick around and we'll have more fun coming.